All right, everyone, let's go ahead and do this. This video is for the homework titled, let's see, homework 5.4. And if you're doing it on paper or you're turning it in person, I would like for you to do it this way, right? To title it page 372, numbers 1 through 4, 7, 9, 16, and 19. Okay, so let's start. Numbers 1 through 4. So numbers 1, read the direction. It says find the exact value of each expression. Right, so we have cosine 240 degrees minus 0 degrees. Right, this is a cosine with a difference formula. Right, so this one is going to break down into cosine 240 degrees, cosine 0 degrees. Right, and then remember, cosine is the opposite, so it'll be plus, that'll be sine 240 degrees, sine 0 degrees. And you just got to figure out what the answer is from there. So cosine of 240 degrees using your unit circle, right? So look at your unit circle if you need help. 240 degrees, cosine is the x. The x is going to be negative 1/2. Okay, 0 degrees, the cosine is the x. The x is 1 plus, right? Sine of 240 degrees, right? Got a couple of little things. I don't know where. Sine of 240 degrees, right? The sine is the y, and it's negative radical 3/2. Sine of 0 is 0, so that's okay. So going in with that, that means I can actually just get rid of that because that just turns to 0. And negative 1/2 times 1, the answer is just negative 1/2. Right. Now, if you were not paying attention and you were thinking, you know what, I can just do this. I can go do a cosine 240 degrees distributed to cosine of 0 degrees. That is wrong, by the way. But if you were going to do that, that's what part B is actually going to look like, which will be wrong, but we still want to figure out, okay, does that work? Right, so if you were to do that, you would, what I just explained with the distributive property, you would end up with cosine 240 degrees minus cosine 0 degrees. Okay, so B is its own thing, but if you were to do distributive property, you would get something like B. And cosine of 240 degrees is equal to, right, again, cosine of 240 is equal to negative 1/2 minus the cosine of 0 degrees, right? And cosine of 0 degrees is 1. So we would end up with negative 1/2 minus 1, which comes out to be negative 1 and 1/2, which is going to be negative 3/2. You see how they're not the same answers? Okay. So these are the right answers for each one. But definitely if you do distributive property and you get this right here and you keep working it out, you'll get negative 3/2, which is not the same as if you had to stay with negative 1/2. Right? So, but that's the answers for A and B. Okay, number 2. 2A is sine 390 plus 120, plus 120 degrees. All right, so we need to figure out what that makes. And then part B is if you were to kind of mess up and you were to do a distributive property, and do sine of 390 and sine of 120. But keep in mind, it doesn't work that way, so don't do it that way. Okay, this is part B. We're just showing how it would look like if you were to have done it the wrong way. So this is sine of 390 degrees plus sine of 120 degrees. Okay, and we'll work on that in a bit. But right now we're doing part A, which is sine of 390 plus 120 by using the sum formula. Remember, the sum formula is going to be, um, well, the sine formula for the sum is going to be sine 390 cosine 390, sorry, cosine 120. Okay, and then for the sine, it's going to be adding because um, it's a sum formula. We use the addition. If you look back at your notes, and then it's going to be cosine 390 and sine 120. Okay, and you're going to go ahead and just figure out the values for each of these. So sine of 390. Right? Oh, where is 390? It's not on a unit circle. You might have to look at round 2 in degrees, right? Or look at round 1, which is 360 all the way around, and then plus 30 more to make 90. So it's the same as 30 degrees. Okay, so sine of 390, the sine is the y value, so that's going to be 1/2. Cosine of 120, right? Cosine is x value, so it's going to be negative 1/2. Plus cosine of 390, and again, that's like 30 degrees. It's going to be radical 3 over 2 times, and sine of 120, sine is the y value. 120 is going to be radical 3 over 2. All right, so working this out, we get 1/2 times negative 1/2 makes negative 1/4 plus, right? So both of these make this already. And then radical 3 times radical 3 is radical 9. And radical 9 is actually just 3. And 2 times 2 is 4. So negative 1/4 plus 3/4 is going to be positive 2/4, which works down to 1/2. Okay. If we were to do it the other way, which is wrong, right? Remember, if we were to distribute it, which would be the wrong way to do it, it doesn't work this way. You cannot distribute the sign like that. Okay, but that would be what B is, okay, which would be the wrong, and you can see it's not going to match up with A. Okay, it's not going to match up with A because that's the wrong way of doing it. Okay, but on part B, they just want us to just explore what's going to happen. Sine of 390 is going to be 1/2. Okay, sine of 120 is radical 3 over 2. And to add that, well, you can't really add that. I mean, you could force it. Since the bottom are 2's, you can say, okay, well, my bottom is going to be a 2. And the top is just going to get added to, and it's going to become 1 plus radical 3. Okay, and you can't add those. So that's the best you can do. You can see that these do not match up. Okay, that's a no-go. Okay, but each of those are the right answer for its own problem. So that's 2. 3. 3 is, now we're talking about radians now. 3 is going to be cosine pi over 6 plus pi over 3. Okay, and we want to find out what that makes. Okay, and that's A. Part B is if we don't do it correctly and we distribute it, we'll get cosine pi over 6 plus cosine pi over 3. Okay, and that's just, I mean, we're not comparing it or anything, but I'm just explaining to you why it's being mentioned, because sometimes you may do this, you may do things that don't make sense, or that may make sense, but it's not allowed in mathematics. Okay, so cosine rule for addition, right? Cosine rule for addition is going to be cosine pi over 6, cosine pi over 3, and then it's going to be opposite, and that's going to be sine pi over 6, oops, and sine times sine of pi over 3. All right, so cosine of pi over 6. All right, look at your unit circle. Now we're back. Now we're going to radians. Pi over 6 cosine is going to be radical 3 over 2. Remember, these are all multiplication except for in the mid in between. And cosine of pi over 3 is going to be 1/2. Minus sine of pi over 6 is going to be 1/2. Sine of pi over 3 is going to be radical 3 over 2. Wow, this one's going to be pretty awesome. Multiplication, multiply straight across. Radical 3 times 1 is radical 3. 2 times 2 is 4. Minus 1 times radical 3 is radical 3. 2 times 2 is 4. Radical 3 over 4 minus radical 3 over 4, that makes 0. That's your final answer. And that's actually the correct answer. Okay. If you do it this way, you get cosine of pi over 6, which is radical 3 over 2 plus cosine of pi over 3, which is 1/2. And again, this one, you can't really do much except add the bottoms, or not add the bottoms, combine the bottom to be a 2, get a common denominator, which they are. So now you can add the top. Unfortunately, the top is just going to be radical 3 plus 1, which you cannot add. And you can see that these are not the same answer. Okay, these are not the same answer, so that's why you shouldn't do it this way. Okay, let's keep going. Number 4, we've got part A, sine 2 pi over 3 plus 3 pi over 4. And part B, this is if you were to do it unknowingly. Part B is sine 2 pi over 3 plus sine 3 pi over 4. Okay, so this is going to use the addition rule for the sine, and that's sine 2 pi over 3 cosine 3 pi over 4 plus cosine 2 pi over 3 times sine 3 pi over 4. Okay. Look at your unit circle and figure this out. Sine of 2 pi over 3. Sine of 2 pi over 3 is going to be radical 3 over 2 times cosine of 3 pi over 4. Cosine of 3 pi over 4 is going to be negative radical 2 over 2 plus cosine of 2 pi over 3 is negative 1/2. Okay, a lot of loose things going on here, guys. Just be very careful. And sine of 3 pi over 4 is radical 2 over 2. Okay, so let's see what happens. Multiply them. So we've got 4 at the bottom. Radical 3 times negative radical 2 is a negative radical 6. That's a plus, but a minus. Right, so I'm going to go ahead and just use the minus. 1 times radical 2 is a radical 2. And 2 times 2 is 4. Right, so then you can combine it some more because they're both 4 at the bottom. You can have a 4. And your final answer is negative radical 6 minus radical 2. No, you cannot put them together. This is your answer. That's the best you can do. If you do it this way right here, or as according to part B, sine of 2 pi over 3, sine of 2 pi over 3 is radical 3 over 2 plus sine of 3 pi over 4 is radical 2 over 2. And if you want to put them together, since the bottoms are both 2, you will get a 2 at the bottom. And the top, you're going to have to add them, but you can't add them. So the best you can do is write it as radical 3 plus radical 2 over 2. And you can see that these are not, they're nothing alike. They're not the same. Okay. So that is, oops, sheesh, a little more than I can chew here. That is 1 through 4. Okay, that's good practice. Just to kind of get you guys down. Okay, 7, 9. Yeah, I'll go next page. Number 7. Number 7 is, let's see. This is 105 degrees. Oh, cool. Back to degrees. I knew I picked some easy ones. Equals 60 degrees plus 45 degrees. And that's true. 60 plus 45 is 105. Right? And it says find the exact value of the sine, the cosine, and the tangent. And remember, we're not doing tangent, so we'll find the sine of 105 degrees. And I think we did something similar to this in class, which is equal to the sine of 60, because this one they're helping us already. They're breaking it down. So 60 plus 45 degrees. We're going to work from there. Right? So sine, remember, sine is sine 60 cosine 45. Okay, plus, and now you swap it around, cosine 60 sine 45. Okay, now look at your unit circle. Okay, sine of 60 degrees. 60 degrees, sine is radical 3 over 2. And I'm not showing you the unit circle. I'm looking at it on my own page, or I'm figuring out in my head, whatever. But you got to look at it on your own. Pause it if you need to look it up. And I'm going a little too fast, right? Because I don't have time to. Well, I'm not gonna make the video pause, where I'm not gonna let the minutes run while I wait. So you can pause it. Sine of 60 is radical 3 over 2 times cosine of 45 is radical 2 over 2 plus cosine of 60 is 1/2 times sine of 45 is radical 2 over 2. Okay, working that out, you get radical 6 over 4 plus radical 2 over 4. And the total final answer is radical 6 plus radical 2 over 4. That is our final answer. Okay, now we're going to do the cosine of 105 degrees, which is the same as cosine 60 degrees plus 45 degrees, right? And cosine is cosine 60 times cosine 45. If I'm going too fast and you need to slow it down, pause it. Okay, you don't need to go at my speed, right? Because I'm trying to make this video as short as possible. Right? And then this is sine 60 degrees times sine 45 degrees. Okay, now look at your unit circle, your main one, not those triple unit circle. Cosine of 60, so cosine is x, so that's 1/2. Cosine of 45 is radical 2 over 2 minus sine of 60, right? Sine is radical 3 over 2 times sine of 45 is radical 2 over 2. So work it out, you get radical 2 over 4 minus radical 6 over 4. And together, you can put it both over 4, and you will get a radical 2 minus radical 6. No, you cannot put it together. That's the best you can do. Radical 2 minus radical 6 over 4. That's the best you can do with the cosine and with the sine. You can see that they look kind of similar. Radical 6 and radical 2, and they're either minus or subtraction, or the last one that we did, you go all the way to the bottom, it's a minus radical 6 and a minus radical 2. So I mean, they all look kind of similar, but they're different in their own ways. Okay, that's number 7. Okay. Number 9, I believe it's number 9. Yep. So we got 7. Now we got to do 9. 9 is 195 degrees. In case you're wondering what that makes, you're suggested to use 225 degrees minus 30 degrees. Okay. So you're going to find the sine and the cosine. Here, I'll use black. So sine 195 degrees equals sine 225 degrees minus 30 degrees. Yes, it's a lot of writing. Okay, yes, I just take a deep breath and don't stop, don't let go until I am done. It's just a lot, and once you get the hang of it, it is much better for you. But at this point, you have to do a lot of it for you to kind of get the repetitiveness of it. The formula for the subtraction of sine is going to be sine 225 degrees cosine 30 degrees minus cosine 225 degrees sine 30 degrees. Okay, and again, if I'm going a little too fast right before I start the answer, go ahead and pause it. Okay, go ahead and pause it if you need a little time right now. Right, we're going to go ahead and look at a unit circle for the sine of 225. The sine of 225 is going to be negative radical 2 over 2. Cosine of 30 is going to be radical 3 over 2 minus cosine of 225 is negative radical 2 over 2 times sine of 30. Sine of 30 is going to be 1/2. Okay, go ahead and combine them together. So this will be negative radical 6 over 4. This negative and negative makes a positive, so plus radical 2 over 4. Final answer, negative radical 6 plus radical 2 over 4. That is your final answer. Okay. Cosine 195 degrees equals cosine, and then use what they suggested is 225 degrees minus 30 degrees. And cosine, remember, is cosine 225 degrees times another cosine 30 degrees. And remember, the rule for the cosine is the opposite. So if the cosine is minus in this case, then we're going to go ahead and add. And the rule for the sine is that it's going to be the same. So if it's minus, then you're going to have to do and use minus again. Okay, for cosine, though, it's going to be opposite. It's going to be adding. And then it's going to be sine 225 degrees and sine 30 degrees. Okay, look at unit circle. Okay, sine of 225 degrees is negative. And pause it if you don't want to see the answer just yet. Cosine of 225 degrees is negative radical 2 over 2 times cosine of 30 degrees is going to be radical 3 over 2 plus sine of 225 is negative radical 2 over 2 times sine of 30 degrees is going to be 1/2. Let's see, did I do that right? That looks exactly the same. Let me double check. Cosine 225, yep, radical 2 over 2. Cosine of 30, yep, radical 3 over 2. Plus, right, because it's the opposite. Sine of 225 is, yep, negative radical 2 over 2. And sine of 30 is going to be 1/2. So it comes out actually to be the same answer. Negative radical 6 over 4. Oh, never mind. Almost the same answer. Positive and a negative. This part I didn't actually see. I was like, it can't be the same answer. I mean, it could be. Because you know how, like, sine and cosine of 45 degrees is the same answer, right? Sine and cosine, you look at 225 degrees is the same answer. So it could be the same answer, but these are not perfectly in the middle. These are kind of a little bit off. So that's why I was like, yeah, it should be a little off. And it is. So final answer, negative radical 6 minus radical 2, all of this over 4. Okay, and that negative belongs with the 6, the radical 6. So that's your final answer right there. Okay. And no, they are not the same. At first, I thought they were going to be the same. Like, that is a little weird, but yeah, they're not the same answer. Okay. All right, that's 9, 16, and 19. Okay, so 16. 16 is, let's see, 15 degrees. I think we've done this in class, right? But you got to figure out how to make 15 degrees, right? And I think we did in class. I think we did 45 degrees minus 30 degrees. Now you can use others, but I'm going to go ahead and try to save time. So, and not make an extra long YouTube video. So I'm just going to go with 45 minus 30. First thing that comes into mind. So we need to figure out the sine and the cosine and the tangent, but let's just do sine and cosine. Right? So we'll do the sine of 15 degrees is the sine of 45 degrees minus 30 degrees, which is sine, and pause it if you need a little time to write it down yourself, 45 degrees cosine 30 degrees. Oops. Minus what did I do? Oh, there it is. Okay. Sorry. Okay, so sine of 45 degrees, cosine 30 degrees, minus cosine 45 degrees, sine of 30 degrees. Okay, work that out. Sine of 45 degrees is radical 2 over 2. And I'm not using parentheses, but if you want to keep it, well, actually, this one I'll use it. Right? You want to just kind of use it to kind of keep your organization. You can totally use parentheses. I actually kind of like it, but at the last couple of problems, I haven't been. So cosine of 30 degrees is radical 3 over 2 minus cosine of 45 degrees is radical 2 over 2. And again, if you don't want me to spoil it, you need to go ahead and pause it while you work on it yourself. Sine of 30 degrees is going to be 1/2. Okay, work it out. You get radical 6 over 4 minus radical 2 over 4. And you get, I believe we got this answer in class. Radical 6 minus radical 2 over 4. And no, you cannot combine those. I know I always tell you that, but sometimes you can. Depends on what kind of radicals, but this one you cannot. Okay. Cosine 15 degrees. And again, we're using the 45 minus 30. So we will be doing cosine 45 degrees minus 30 degrees. The rule for the cosine, look at your notes for the difference rule for cosine. Okay, pause it if you need to because I'm about to spoil it for you. It's cosine 45 degrees, cosine 30 degrees. And the cosine's the opposite, and that'd be sine 45 degrees, sine 30 degrees. Okay? Now look in unit circle. Cosine of 45 is radical 2 over 2. I'm not using the parentheses, so less writing for me. Cosine of 30 is going to be radical 3 over 2 plus sine of 45 is radical 2 over 2 times sine of 30 is going to be 1/2. And this gets you to radical 6 over 4 plus radical 2 over 4. And this one just comes out to be positive. Radical 6 plus radical 2 over 4. Okay, and that's a sine on top in red, and that's a cosine on the bottom in blue of 15 degrees. Right? That was number 16. Right, and 19 is 13 pi over 12. All right, so this one, 19, and I'll just mark it off. Okay. 19. We need to do 13 pi divided by 12. Okay. So you can come up with all kinds of things, but whatever first comes into your mind, and we did this in fifth period, you can always change it to a degree because that makes it a little easier to add up things on the unit circle. Right? I'm gonna go ahead and just kind of stick to it. So I'm looking for things over 12, right? So I'm looking for things over 12 that makes 13. So you can go 7 and 6. Now you can go 7 pi over 12 plus 6 pi over 12, right? But 6 over 12, I mean, that does reduce down to pi over divided by 6 and 2. This one is on the unit circle, so I can do this. But 7 pi over 12, that's not on the unit circle, so I cannot use that. So I can't do 7 pi over 12 and 6 pi over 12. So I can't do that. What else makes 13? Right? So how about 7 and 8? No, not 7 and 8. 9 and 8, right? Does that work? No, the 9 and 8 is not 13. What am I doing? 9 and 9 and 9 and 4. Does that work? Yeah, let's see. 9 pi over 12 plus 4 pi over 12. That makes 13, right? And 9 pi over 12, if I reduce it, what do I get? Divide both of them by 3, I get 3 pi over 4, and that is on the unit circle. And then if I reduce 4 pi over 12, what does that make? Right, so that makes, divide both by 4, I get 3. Actually, I don't get 3. What am I doing? Divide both by 4, I get 1 pi over 3. Right, divide by 4, I get. So pi over 3 is on the unit circle, so I can change 13 pi over 12, and this is just using radians, okay, to pi over, 3 pi over 4 plus pi over 3, okay? So that's what I'm going to do. So I'm going to go ahead and do a sine of 13 pi over 12, and this is just one answer. This isn't, but the answer will be the same, the result, okay? But this is just one way at getting the answer, okay? So there's many ways. So I'm going to be using sine 3 pi over 4 plus pi over 3. Okay? And that makes, let's see, the sign for the addition is sine 3 pi over 4 cosine pi over 3. And sine is the same, so you use addition. And now it's cosine pi over 3 times sine. Sorry. Backtrack. I'm like, that looks a little weird. Plus cosine. I usually don't switch the angles. That's usually how you get mixed up. I switch the trig function only. So cosine 3 pi over 4 times sine pi over 3. Okay, cosine of 3 pi over 4, or sorry, sine of 3 pi over 4 is going to be radical 2 over 2. Cosine of pi over 3 is going to be 1 half. Plus cosine of 3 pi over 4 is going to be negative radical 2 over 2. And sine of pi over 3 is going to be radical 3 over 2. So answer is radical 2 over 4 plus, a minus, so it'll be just a minus radical 6 over 4. So your final answer, 2 minus, final answer, radical 2 minus radical 6 over 4. That's for the sine. For the cosine, I'll use purple because this is the last one I'm celebrating. Cosine 13 pi over 6, sorry, over 12. I 13 pi over 12 equals sine, and 13 pi over 12 is, and I'm using 3 pi over 4 plus pi over 3. Oh, why did I put sine? It's cosine. All right, cosine rule is cosine 3 pi over 4 times another cosine pi over 3. And cosine is the opposite, so minus, and then it's a sine both times. So sine 3 pi over 4 times sine pi over 3. Okay, this makes cosine of 3 pi over 4. Cosine of 3 pi over 4 is negative. I'll use parentheses. Negative radical 2 over 2, just because I am done after this, and you are too, I hope. Cosine of radical 3, cosine of pi over 3 is 1/2. Okay, again, if you want to do it yourself without me ruining it, pause it. Stop letting me talk. You need to pause it. Sine of 3 pi over 4, it's going to be radical 2 over 2. And sine of pi over 3 is going to be radical 3 over 2. Okay. So final answer, well, working towards it, radical 2 over 4 minus radical 6 over 4, which is going to give the final answer of negative radical 2 minus radical 6. All of this over 4, and no, you cannot combine those together. That's the best you can do. Attaboy or attagirl. Okay, that is a wrap. Have a great weekend. Turn it in before